I welcome you all to lecture number 17 of this course. Now we are discussing the different methods of defuzzification, and we have already understood that we need some defuzzification to get the crisp output value. Okay. Now, as I told in the last class, there are several methods of defuzzification. And so far as I can remember, in the last class, I discussed one method that is called the center of sums method. So this is the method. Now to repeat that, let me go back to this particular diagram. Now let me repeat for the fired rule 1. So the fuzzified output is nothing but this truncated triangle. And for the fired rule 2, the output is nothing but this particular truncated triangle. Okay. Now to find out the combined control action considering both the fired rules. So what I do is, so this particular area and that particular area, okay, these two areas are superimposed. And mathematically speaking, we are going to implement the OR operation, that is a logical OR operation, and that is nothing but the union. Okay. Now from the first fired rule, so I'll be getting this particular figure as the output. For the second fired rule, so I'll be getting this particular figure as the output. The moment we consider the union, so I'll be getting the combined output is nothing but this, which is shown by this solid line. Okay. So let me repeat, by using the concept of union, the combined output which we will be getting is nothing but the area shown by the solid line. Okay, so this is the solid line. So this shows in fact the output of the combined control action. Okay, after considering both the fired rules. Now we'll have to find out the crisp output corresponding to this particular fuzzified output, that is nothing but the area. Now to get the crisp output, actually what we do is we take the help of some defuzzification method. And as I told in the last class, it is very simple. So what we do is, according to the center of sums method, corresponding to the first fired rule, we try to find out the area of the truncated triangle, which is nothing but the trapezium. And all of us, we know how to determine the area of this particular, the trapezium. Okay. And from symmetry, I can also find out what should be the centroid, that is or fj. And knowing the values for this area and center of that particular area, and by using this particular expression, you can find out what is the crisp output according to this center of sums method. Now this method is the oldest one and it has got some drawbacks. Drawbacks in the sense, supposing that I'm using one nonlinear distribution for this particular membership. Okay, for example, say I'm using say Gaussian distribution or sigmoid distribution or bell-shaped distribution, something like this. Now, how to find out the area under that particular the curve, the truncated area of the membership function distribution. And all of you know, if it is a nonlinear distribution, there is no way out, but you'll have to go for integration. And integration is computationally very expensive. So your center of sums method is going to take a reasonably high CPU time to determine the crisp output. And if it takes significant amount of time to determine the crisp value, okay, so this particular method cannot be implemented online. Okay. Now to implement it online, and there is another drawback in fact that I'm going to discuss. So what we do is if we just concentrate on this method of center of sums, you will be able to understand. So corresponding to the fast fired rule, so I am getting this as the truncated area. Corresponding to the second fired rule, I am getting this as the truncated area. The moment we consider the two rules one after another, so this particular common area, okay, this will be repeated twice. Okay, that means this common area I'm going to consider more than once, that means twice, and that will create some actually inaccuracy in the model. I hope you have understood. So this particular subregion is the common to both that particular truncated area, and this will include, in fact, some sort of inaccuracy in the your calculation. Okay, so these two are the drawbacks of this center of sums method. Now to overcome this, we take the help of another method, and that method is known as centroid method. So I'm just going to discuss the centroid method, and all of you please concentrate on the figure B. So I'm going to consider the same, the truncated area corresponding to the output of the combined control action. And here what we do is, so this particular area is divided into a large number of small regular subregions. Okay. For example, say this same truncated area, the combined control action, I'm going to divide into say one right angle triangle denoted by one rectangle denoted by 2, another right angle triangle denoted by 3, one rectangle denoted by 4, another rectangle denoted by 5, another right angle triangle denoted by 6. Now, once you've done this, so this particular, the drawback of center of sums method, that a particular subregion is considered more than once. So that particular drawback can be eliminated. I hope all of you are clear. Now what you do is, once you've got all such regular subregions like right angle triangle, rectangle, and all such things, very easily we can find out the area and center of area. All of you know how to find out the area of this particular triangle. That is half into base into this height. And you know how to find out the center of area. That is nothing but 2/3, 1/3. All of you know. Okay, for this type of triangle, the center of area will be 2/3, 1/3. Okay. Now, 2/3, 1/3 division on the base. So you'll be getting that particular your the center of area. For this rectangle, you know how to find out the area and center of area. Okay. And once you've got the area and center of area information for each of these regular subregions, now I can take the help of the mathematical expression like this. So this is nothing but the crisp output is summation I equals to 1 to n ai. This should be fi. I'm sorry, this is a mistake. Okay, and divided by summation ai equals to n ai. So using this particular formula, very easily you can find out what should be the crisp output corresponding to this your centroid method. I'll be solving one numerical example in today's class. You just wait a little bit, things will be 100% clear. Now the third method, that is nothing but is your mean of maxima method. Mean of maxima method. Now here in second method, that is the centroid method, one of the drawbacks of center of sums method could be eliminated. What is that? The same subregion will not be considered more than once. Okay. But once again, this remains actually computationally expensive. Just a minute, I've got one very urgent call. Just 1 minute. Atanu? Hello, Atanu? Gopal Babu এসে গেছেন ল্যাবে, তুমি একটু যাও। হ্যাঁ হ্যাঁ, ঠিক আছে, আমার ক্লাস চলছে একটা এখন। হ্যাঁ, I'm sorry for the disturbance. So let me once again come back. So one of the drawbacks of the center of sums method could be eliminated. That is the same subregion that is not considered more than once in the centroid method. But the computational complexity of the first method, that is your center of sums method, okay, that could not be eliminated. Once again, this will remain computationally very expensive, okay, might be slightly less than this, but it is computationally expensive or equally expensive. Now to overcome that, we took the help of your mean of maxima method. And this method is computationally very fast, but this is a more approximate method. Okay. So we get a computationally faster method, but at the cost of accuracy. And what is this method? Method is very simple. So what you do is you try to identify the range for the output corresponding to which you get the maximum value for this particular membership. Okay, and you can see that the range for the output is starting from 4 to 7. Okay, and here you are getting the maximum value of membership. And once you have identified the range for the output corresponding to which you get the maximum value of membership, okay, you try to find out the mid value of that particular range, okay, and that particular mid value of the range will be the crisp output according to the mean of maxima method. Okay, so these three are the popular, the method of defuzzification. And as I told, just after a few minutes, I'll be solving one numerical example, and I'll show you that I'll show you that it can be done very nicely. Okay. Now, uh, before I proceed further, let me ask you one thing. Now, out of these three methods of defuzzification, which one is the best one? Can anybody answer? Out of these three methods of defuzzification, so which one is the best one? You are allowed to talk one at a time. Can anybody tell me which one is the best method? Yes, tell me.
Sir, we will need to optimize this again.
Yeah, you are 100% correct. You are 100% correct. Okay. Now, if I tell you that which one is the best one, okay, we cannot answer. All are good. Although each of these particular method is having its own merits and demerits. Okay. Now, what you'll have to do is you'll have to take any one. We'll have to optimize the performance of the fuzzy reasoning tool or the fuzzy logic controller, okay, so that it performs in the optimal sense during its working. Okay, let me take a very simple example. Okay, and I'll request you not to mind. Okay, let me take a very simple example which has occurred to my mind. Let me speak out, but I'm requesting once again, nobody should mind after hearing that particular example. Okay, now supposing that this is a fact, you believe me, this is a fact in life. Now you are doing say BTech undergraduate, or you are doing MTech or PhD, whatever you are doing. Okay, after the completion of your course, whether you are doing BTech or dual degree MTech or regular MTech or PhD, whatever may be, okay, you will be joining somewhere, okay, and you'll have to perform in the optimal sense. Okay, now supposing that in one organization, whether it is a teaching institute, research institute, or say industry, hardcore industry, okay, supposing that people are coming after getting their degrees from different institutes, One class of institutes, of course, is IIT. Another class of institute could be NITs. Another class of institute could be universities. For simplicity, let me take these three examples. Okay. So some of the students will be coming through the IIT system. Some of the students will be coming through the university system. Some of the students will be coming from the NIT system. Now, your promotion, your future will depend on the way you perform in that particular the job. Okay, whether you are coming from NIT, university, or IIT, people, others are not going to see that. They'll see your depth in knowledge. They'll see your performance. Are you getting my point? If the performance is good, they'll not mind whether you are coming from, say, any university or any NITs or IITs or new IITs or whatever maybe. On the other hand, if the performance is good, they'll not see your source, they'll see your performance. This is the fact of life. You take it from me. Now, supposing that your figure B is nothing but IIT system compared to others is more accurate system. Okay, let me put it like this. Might be A could be NIT system, C could be university system, or A and C could be vice versa. Okay, but if you compare these three systems, might be your IIT system could be slightly better. Okay, but as I told, your training and other things will be done based on little bit of merits and demerits each of the system is having. No system is foolproof. Each system is bound to have some merits and demerits. Okay, it depends on the student who train himself or herself so that he or she can perform in the career, in his future career. Okay, that matters. Same is true here. Okay, so you can use any of the three dephagicification methods. Okay, and training will be done accordingly. Okay, so that my physiologic controller may perform in the optimal sense. Okay, so I'll request all of you to make the fundamentals clear, whether you have come for this system, that system, or any other system, whatever may be. Okay, now you should be very strong in fundamentals, and if you are strong in fundamentals, nobody can stop. Okay, you just take it from me, nobody can stop you. Okay, now, so the point which I'm going to make, the method of dephagicification, which method of dephagicification is not the prime factor. Take any one. Okay, you train your physiologic controller with the help of one optimizer, say genetic algorithm, with the help of some training data. Okay, and after that, my physiologic controller will be able to perform in the optimal sense. I hope I am clear to all of you. Okay, now based on this particular information, I'm just going to solve actually one numerical example. Now this particular numerical example is very simple. Okay, so this numerical example I have taken related to motion planning of a mobile robot, very simple mobile robot, like a point mobile robot. Okay, and you will be astonished to listen that with this problem only, I started my PhD work. Okay, after that, I made it very complex. Okay, but this is the very simple problem with which I started my own PhD work. Okay, although I made it very complex at the end, but initially I started with this particular numerical example. Okay, and very purposefully I have kept it in my textbook also, most probably. So this particular the numerical example based on Mamdani approach. Okay, now let me tell you the statement of the problem which I've designed. Now before I give the statement, let me show you that figure, the picture of this particular problem. Very simple problem, and this problem is known as find path problem in robotics. Now the statement of the problem is such, supposing that I have got a very hypothetical point robot, okay, and S indicates the starting position of that particular point robot, okay, and G is nothing but the goal of that particular point robot. Now, supposing that there is no such moving obstacles in the environment, what is the optimal path in terms of the time taken? It is very simple. You start from here and the robot will try to reach this particular goal, okay, by following this particular path, because this is the globally optimal path in terms of your the cover distance, okay, between this particular the initial point and the goal point. But unfortunately, there are some moving obstacles on the environment. For example, say, I have got a circular obstacle. So this problem, as I told, is a very simple problem, okay, on 2D plane. But actual problem is in 3D space, okay. Now, what happens here? So this obstacle, the moving obstacle O1, so this is moving in this particular direction with some speed. O2, the second moving obstacle, is moving in this particular direction. O3 is another obstacle moving in this particular direction. O4 is another which is moving in this particular the direction. Okay. Now, if there are any such moving obstacle, so this particular path may not remain the collision-free path. See, before I try to find out the time optimal path or distance optimal path, I'll have to ensure that the path is collision free. If the path is not collision free, so you cannot find out your optimal path. So first assurance has to be given that this is a feasible path. Now, out of all such obstacles, which one is the most critical obstacle? So if you compare their movement and the relative position with respect to the planning robot, so this O2 will be the most critical obstacle, okay, because it is going to collide with this particular the planning robot, okay. So in the first step, the robot will have to avoid collision with this O2. Then once again, it will replan, try to find out which one is the most critical obstacle at that particular instant or predicted instant. Okay. Accordingly, you'll try to find out another deviation to avoid collision. And ultimately, the point robot might be able to reach this particular the goal. Okay. So I hope you got the idea of this particular the physical problem. Now I'm going to give a statement of the problem. Let us consider a problem scenario related to navigation of a mobile robot in the presence of four moving obstacles, O1, O2, O3 and O4. Obstacle 2 is found to be the most critical one. Our aim is to develop a fuzzy logic based motion planner that will be able to generate the collision free path for the robot. There are two inputs, namely the distance between the robot and the obstacle. I'm going to show you on the figure, and the angle GSO2 for the motion planner, and it will generate one output, that is deviation. As I told, this is the initial problem. After that, we made it very complex. Okay, so I'm not going for that particular complex problem. So once again, let me see this particular the figure. What are the inputs? The inputs are the distance between the planning robot and the most critical obstacle. So might be this particular distance. And what is the included angle? Angle is nothing but angle between GSO2. So this particular angle. Are you getting my point? So these two are the inputs. One is the distance, another is the angle. And based on which your planning robot is going to find out what should be the deviation angle so that it can avoid collision with this particular obstacle. Okay. So let us see how to, let us see the other part of the statement of the problem. The distance is represented using four linguistic terms, that is very near, near, far, and very far. Whereas the input angle and the output deviation are expressed with the help of 5 linguistic terms such as ahead left, then comes left, ahead right, and right. Okay, I'm just going to show you that particular picture for the membership function distribution. Okay, you see, this is nothing but the membership function distribution for the distance. Please put up your audio. I think one member joined and I'm requesting him or her to put the audio off. So the distance is expressed using very near, far and very far. And for simplicity, I'm going to consider the triangular membership function distribution. Okay. And for this particular, your angle input and the deviation. So I'm using 5 linguistic terms. A stands for ahead. That means if I'm the planning robot, so my ahead direction is my ahead. Okay. Then there will be ahead left towards my left. Then there will be left. Similarly, towards my right side, we'll have ahead right and right. Okay. So once again, the angle is expressed using 5 linguistic terms. That is ahead left, and left. Then we have got ahead right and right. Similarly, the deviation is also denoted by 5 linguistic terms. That is ahead left, ahead right, and right. Now here you can see I put some numerical values 0, plus 45, plus 90 degrees, minus 45, minus 90. What does it mean? 0 means what? I'm moving towards ahead. Okay. So this particular angle, if you see, corresponding to the highest membership, that is 1.0, the numerical value of the angle is 0. That means I'm moving exactly in the ahead direction. And that is a crisp set. But what is the fuzzy set corresponding to ahead? That is nothing but this particular triangle, and where range will vary from minus 45 to plus 45. Similarly, ahead right, where the crisp corresponding to the maximum membership value is plus 45, okay, might be towards my right, ahead right, and right corresponds to your 90 degrees, okay, and ahead left, here crisp value corresponding to minus 45, and this is the fuzzy set expression for ahead left, and this is the left membership function distribution. Okay, now why did I select this type of the values for the angles? Okay, now as I told that whenever I face any problem, I always ask the way we human beings solve the problem. Okay, do you know how much is the angle of vision for our system? So this particular angle of vision, it is slightly more than your 120, but of course less than 180. And it varies from person to person. It depends on the structure of the face, the relative position of the eyes, and that vary from person to person. Okay, so we have got one angle of vision, might be 150 degree, okay, or 160 degree, or 170 degree, okay, but generally it does not become equal to 180. But for simplicity, here I have considered minus 90 to plus 90 for the robot, as if the angle of vision is 180 degree. And the robot doesn't know what is happening on its backside. Okay. So this is the way actually we define the membership function distribution for the two inputs, distance and angle, and one output, that is nothing but the deviation. Okay, now this deviation, angle of deviation, is the angle through which the planning robot should deviate to avoid collision with the moving obstacle. I hope I am very much clear regarding the database of the two inputs and one output. Okay, the distance and angle are the inputs, and the output is nothing but the deviation. Okay, so this is the way actually we define the membership function distribution for your the two inputs and one output, that is nothing but the database. Now another thing I just want to make it clear. There are four linguistic terms for the distance and there are five linguistic terms for the angle. So how many combination of the input variables are possible? It is very simple. 4 multiplied by 5. Okay. There will be 20 combination of the input parameters. So there will be 20 rules in present in that particular the rule base. Okay. I'm just going to define that particular rule base also. Okay. And we can further optimize that particular rule and we can make a very optimized rule base also. Okay. I'll be discussing all such things. But before that, let me finish this statement. Distance is represented using four linguistic terms, namely very near, near, far, and very far. Whereas the input angle and the output deviation are expressed with the help of five linguistic terms such as ahead, ahead left, left, ahead right, and right. Okay, so this is the statement. Okay, this is your the graphical representation or the figures for the figure your problem. These are the membership function distribution of the two inputs and one output. This is the rule base. Now this rule base, how do you design? Depending on your own information on the problem, manually we design so this particular the rule base. And as I told, there will be 20 rules in the rule base. The first rule is something like this. If distance is very near and angle is left, then deviation is ahead. If distance is near and angle is ahead, then deviation is right and so on. Okay, so this is the way actually we design the manual rule base. But remember, this particular rule base may not be optimal in any sense. Okay, so I'll have to use one optimizer, say genetic algorithm or any other optimizer to find out the optimal rules, to identify the optimal rules with the help of your training scenarios. Are you getting my point? So we can optimize it further. But for the time being, I'll show you based on this particular manual rule base, how to determine mathematically the output corresponding to a set of inputs. So the remaining part of the statement of the problem is as follows. Determine the output deviation for the set of inputs. Distance is denoted by D equals to 1.04 meter. I have taken at random. Okay, and the angle GSO2 equals to 30 degree. Once again I have taken at random. Use Mamdani approach to determine the output, that is the deviation angle. Use different methods of dephasification. So all three methods of dephasification I am going to use to determine the numerical value corresponding to the output of this particular the fuzzy resisting tool. Okay. Now you see how to find out the solution. Very simple. Once again, the input distance is 1.04 and the angle is 30 degree. So go back to the database. So distance starts from 0.1 meter to 2.2. How to determine this particular range? Once again, this range can be initially determined based on your experience, and we can also optimize what should be the effective range for these particular inputs and output. Okay. Now here 1.04 means where? I'm here. This is 0.8. This is 1.5. So might be I'm here. Now if I'm here, so this same distance can be called far with some membership function value. It can also be called near with some other membership function value. Okay. Now this angle 30, so this is the angle 30, okay. I'm sorry, the angle 30 I'm here, that is the input side. So 30 can be called ahead right with some membership function value. It can be called ahead with some other membership function value. And as I told in the last class, and that was pointed out by one of your friends, that if this ahead right corresponding to the ahead right, if I get membership function value say x1 or say mu1, and if I get membership function value corresponding to A is mu2, whether mu1 plus mu2 is equal to 1.0, answer is yes. Okay, because see, if you just calculate numerically, you'll find the mu value here plus the mu value here will become exactly equal to 1.0. All of you please check it. Okay, so let me repeat, this 30-degree angle can be called ahead right with some membership function value, and it can also be called ahead with some other membership function value. Okay, now how to determine, all of you know, very simple mathematics. Class 9 level or class 8 level your geometry. Okay, now this is the membership function distribution for near corresponding to this 1.04. So supposing that this is the membership function value denoted by x, the range for this right angle triangle 0.8 to 1.5, and along y-axis we have got 0 and this is 1.0. The moment I am passing 1.04, so I am going to determine what is x. So this particular triangle and this your bigger triangle, they are similar triangle. So use the principle of similar triangle. Very simple. So x divided by 1.0 is nothing but 1.5 minus 1.04. So this particular divided by 1.5 minus 0.8, you can find out very easily what is x. This is one way of determining. There are some other methods, very simple. So what you do is you find out the coordinate of this particular point, find out the coordinate of this particular point. What is the coordinate? 1.5 comma 0. What is the coordinate here? 0.8 comma 1.0. Find out the equation of this particular straight line. All of you know y equals to mx plus c. There are two unknowns, two known conditions. M and C can be determined. So very easily you can find out the equation of this particular straight line. And if I know the equation of the straight line, if I supply x, can you not get y? Yes, that y is nothing but your mu value. Okay, so it can be determined, very simple calculation. Okay, and the distance of 1.04 meter may be called near or far, as I told. An angle of 30 degree may be either ahead or ahead right, and corresponding to distance equals to 1.04, I can also find out the mu. So mu corresponding to near is 0.6571 and mu corresponding to far is nothing but 0.3429. If you just add them up, this will become 1.0. Similarly, corresponding to this angle of 30 degree, it is ahead with membership function value 0.3333. It is ahead right with membership value 0.6667. Once again, if you add them up, you'll be getting 1.0. Now, there are two possibilities for the distance near and far. There are two possibilities for the angle ahead and ahead right. So how many combinations of the fired rule? 2 multiplied by 2. So there are 4 such combination, possible combination. And what are the fired rules? If distance is near and angle is ahead, then deviation is right. This you can see from that manually constructed rule base, which is present in the rule base table. Next is if distance is near and angle is ahead right, then deviation is ahead. If distance is far and angle is ahead, then deviation is ahead right. If distance is far and angle is ahead right, then deviation is ahead. So these 4 rules out of 20 are going to be fired corresponding to the set of input parameters, that is distance equals to 1.04 and your angle equals to 30 degree. I think I am clear to all of you. Now, so this I'm going to discuss with the help of the next figure. All of you will understand. So this figure shows the 4 fired rule. This is the first fired rule. If distance is near, angle is ahead, deviation is right. The second fired rule, if distance is near, angle is ahead right. So this is the output. Okay. Similarly, this is the third fired rule and this is the fourth fired rule. Okay, now I'm discussing Mamdani approach. So what I'll do, I'll pass one set of inputs, that is the distance input 1.04 meter. The angle input is your 30 degrees. Corresponding to this 1.04, you draw one vertical line here. Corresponding to your 30-degree angle, you draw one vertical line here. Okay, now you concentrate on the first fired rule. It is going to intersect here. It is going to intersect here. So this is mu corresponding to near. This is mu corresponding to ahead. You compare these two mu values, take the minimum. So I'll be getting this particular truncated area as the output. Similarly, you concentrate on the second fired rule. Okay, this is the mu corresponding to near, the mu corresponding to ahead right. Consider the minimum. So you will be getting this particular shaded portion is your output for the second fired rule. Okay, corresponding to the third fire rule. So this is the output, the shaded portion. Corresponding to the fourth fired rule. So this shaded portion is the output. Now you see, I have got individually the output of all 4 fired rules. Now I'll have to combine. Okay. Now if I combine these 4 fired rules, I'll have to superimpose. So all such truncated area shown by the shaded portion will have to superimpose using the principle of union. That is the logical OR operation. Okay. Now if I combine all 4 your shaded portion area, okay, so I'll be getting this type of your the combined control action. You can see this particular area. All of you please try to get it. Have some practice. So you'll be getting this shaded portion is the output if I compare, if I consider all 4 fired rules. Now once again, this is the fuzzy-fied output. You directly cannot use as the angle of deviation to avoid collision. So what we do is, corresponding to this shaded portion, we try to find out your deviation, that is the crisp value of deviation. Once again, use the method which I have already discussed, center of sums method. And according to the center of sums method, for each of the 5 rules, I try to find out the area and center of area. For the first 5 rule, so this is the output. I can find out the area and center of area. Now this is a combination of one right angle triangle and another is a rectangle. So individually we can find out area and center of area, area and center of area. Okay, and all of you know your first year applied mechanics course. Okay, or even your class 11, 12 physics also you have studied how to find out the center of area. So you can find out the area and center of area. Similarly, for the second fired rule, corresponding to this trapezium, you can find out area and center of area, area and center of area, area and center of area, according to the center of sums method. Okay. Then you find out the crisp value, area multiplied by center of area, plus area multiplied by center of area, plus area multiplied by center of area, area multiplied by center of area, divided by the sum of all area values. I'll be getting the crisp output as 19.5809. Okay, so this is the crisp output corresponding to your center of sums method. Now you go for the centroid method. Okay, once again, principle I have told. So this fuzzified combined output, this is divided into a large number of small regular subregions. For example, the first one is a right angle triangle. Second one is a rectangle. Third one is a right angle triangle. And the whole thing, the fourth one is another rectangle. Okay. You find out area and center of area, area and center of area, area, center of area, area and center of area. Then you use this particular technique to find out the crisp value. And if you calculate, you'll be getting 19.4450. Okay. So this is how to implement the centroid method. Then comes your mean of maxima method. Very simple. So if you see this combined control action, for this range of output, there is a deviation. You are getting the maximum value of mu. Okay. Find out the mean of that or the mid value of that particular range. And fortunately or unfortunately, it is going to give 0 degree deviation. That means you'll have to move ahead according to this mean of maxima. Now you see the difference. According to the mean of maxima, for the same method, the crisp is 0. According to the centroid method, it is 19.4450. And according to your center of sums method, it is 19.5809. One is IIT, another is NIT, another is university. Okay. Now nothing is foolproof. So what you do is you do the training, you train yourself knowing that there is little bit of error. Okay. You train yourself with the help of some training scenarios, with the help of some optimizer, so that you can perform well in future in your professional career. Okay. Because you see, what you are doing is we are modeling your brain, human brain, using the concept of fuzzy sets. Okay. So this is the way actually your fuzzy reasoning tool works. Okay. I hope I'm crystal clear to all of you the working principle of this particular the Mamdani approach of fuzzy reasoning tool. Okay. Now there is a little bit of time, so I'll give you the opportunity if you want to ask something regarding the Mamdani approach. Whatever I discussed today, you can ask me, and I'm going to start with the second approach, that is Takagi and Sugeno's approach, in the next class. Now tomorrow is holiday, so tomorrow I'm not going to take your class. So your next class will be on Saturday. Okay, so Saturday, that is 3rd October, we are going to start from 12. Saturday as usual from 12 to 1:30. So tomorrow is holiday. Tomorrow I am not going to take your class. Okay. Now before I stop, you do one thing. You ask me if you have any doubt regarding the things which I've discussed in today's class or even before, whatever I discussed. If you have any doubt, so I'll give you that opportunity to ask me. Okay. So now you can start.
Hello, sir.
Yes.
Sir, I am Shampad.
Yes.
Sir, I want to just understand the significance of these terms actually in which by linguistic terms by which you describe the angles, that is ahead, left. Actually, sir, how do we define these terms actually in terms of angle? Means what is the significance of these terms, linguistic terms, ahead, left?
Okay. Okay. Now, as I told, that these particular tools are very efficient for the problem which are ill-defined, whose physics is not known, whose mathematics is not known. And fortunately or unfortunately, that is the case with most of the real world problems. I'll take a very simple example. You will be astonished to listen that. Okay. See, out of all the machining operation, which one is the easiest one? Can you tell me?
Turning.
Yes, and that too straight turning. And you take it from me, till today, there is not a foolproof differential equation corresponding to even straight turning. You forget about other very difficult problem. Okay. Now, why I'm telling? Because you do not have the complete picture, the physics or mathematics. Okay. But still, I want to get some acceptable solution. How to do it? We human being, we use our head, our knowledge to approximately carry out some analysis of the problem. Might be based on my experience. So I am defining if the distance is lying between this and this, it can be called very near. If it is lying between this and this, it can be called near. But there is no guarantee that that will be very near, suitable range for very near and near. So initially, to start with the problem, you assume based on your experience of the problem. The problem is so complex, you do not know exact physics. Okay, but you have some experience. Okay, so you can imagine something to start with. Then you take the help of optimizer with the help of some training data. So optimizer is going to give you what should be the most suitable range for very near distance or near distance or far distance. This is the way actually we do. Okay, for example, say whenever you join, say IIT Kharagpur in the PhD program or MTech program or BTech program, okay, you have a very rough knowledge sort of thing. We people, we are all optimizer, all the teachers, we are all optimization tools. Okay, and our aim is to guide you in the proper direction so that you can generate your knowledge base in the optimal sense. You can perform in future in the optimal sense so that you can establish yourself in your professional career. Okay, so we are all genetic algorithm for your PSO and others. Okay, and how to retain that particular information which we are going to give you. To retain that, we need some brain that is in terms of the structure of fuzzy reasoning tool, or it could be a structure of neural network, which I'll be discussing after some time. So I hope you have understood the role of fuzzy logic or fuzzy reasoning tool, the role of optimization tool or training tool, the role of training data so that you can get the optimal knowledge base. Okay. So after you get degree from this particular institute, your knowledge base will be too much prepared, too much trained to solve any real world problem. Okay, but initially, whenever you joined IIT Kharagpur, so your database, rule base, that may not be the proper. You had some rough idea, some manually constructed database and rule base. Now, through this particular training, your knowledge base are going to be trained so that you can perform in the optimal sense in your professional career. I think I'm clear. Okay.
Thank you, sir. Sir, according to this explanation, I just want to confirm that from the database figure that you have shown, for example, in case of AHEAD, so it is the membership function is lying between the angle minus 45 degrees to 45 degrees.
Exactly.
So in this case, for AHEAD, we'll consider angles within only this range. So
no,
is this the concept like this?
You see, during the training, we'll give some initial range. Say minus 45 to plus 45. After the training is over, okay, so this range will be optimized. Might be the optimal solution will be minus 29 to plus 29 is the optimal range for AHEAD. That you do not know initially. It depends on the nature of the training scenarios. It depends on the optimization tool. Okay, so that you can optimize your own your database and the knowledge base. Now, of course, it depends on the training data. It depends on the optimization tool like us. Okay, if you get a very good teacher, there is every possibility that you'll be getting proper training. Okay, and your knowledge base will be optimal like anything. Okay, and you are going to perform in the very optimal sense. Okay, I hope you are clear. It depends on the strength of the optimization tool. It depends on the nature of the training data. Okay. Accordingly, your knowledge base and of course your own effort. The teacher is trying his level best, and we have got a very good your training data also. But if the student doesn't work hard, does not want to learn the new things, so I don't find any hope. Okay. I hope I'm clear. No?
Sir,
yes, sir.
sorry for the disturbance. I have a class now. I'm falling to this class. Can I leave, sir?
Yeah, definitely. So I'm just going to stop it.
Thank you.
Sir,
Sir. Thank you.
Please.
Sir, I have another question, sir. When we
You see, some of the students are going to leave now. So I'll request you to remind me on Saturday. So before I start Saturday's class, okay? So please ask me. I'll try my level best to give clear your doubts. Okay?
Okay, sir.
Let me stop here today.